Alright, continuing with chapter exercise 12.1. Question number 6. An isosceles triangle has a perimeter. So boundary, okay, boundary means what? AB plus BC plus AC. When we add that, how much is it? 30 centimeter. And each of its equal sides is 12 centimeters. So isosceles triangle means we already know two sides are equal. So we're going to take the two equal sides to be AB and AC. Alright, so you can see both of them are equal to 12 and 12 centimeter. Alright, so question is find the area of this triangle. So here, without knowing the third side, that is BC or C, we cannot find the area using Heron's formula. Right, so first thing is first, we'll try to find C or the third side. Okay, so let the sides of the triangle be A12, B12 and C. We're going to find it first. How do we find? We'll get it from the perimeter, right? Because perimeter means simply the boundary. So A plus B plus C, right? The boundaries equals how much? 30 centimeter. And now from here we know A and B are 12 and 12. So 12 is 24. If it goes to the other side, it's going to become minus 24. And then 30 minus 24, we're going to get 6 centimeters. So now we know all the three sides: 12, 12 and 12, 12 and 6. We just got C. Right, now in order to use Heron's formula, we still have to find the semi-perimeter. So semi-perimeter, like we did in a previous video, you can always do A plus B plus C by 2. But here we'll just go simply direct perimeter divided by 2, half times, right? Half times the perimeter. Okay, they've given us perimeter is 30 divided by 2. We're going to get small as the semi-perimeter to be equal to 15 centimeter. Now we know everything, we just have to use Heron's formula straight away. Okay, A is 15, H is 15, minus A is 12, and again 15 minus 12, and then 15 minus 6. Now let's open number again. So 15 will remain as it is. 15 minus 12, 3. 15 minus 12, 3, and then 15 minus 6, 9. Right, then once we're done with that, we can multiply these two, 3 3s are, we're going to get 9, right? So we can see that we have a pair that is 9 square, so this will come out, and then we're going to get the area of the triangle to be equal to 9 root over 15 centimeter square. All right, question number 7. The length of the two sides of a right triangle. So remember, okay, right triangle contain a right angle differ by 2 centimeter. Here they have given us the area of the triangle, how much? 24 centimeter square. But they want us to verify by using the Heron's formula. Okay, now if you look at this right triangle here, we're asked to prove that by using Heron's formula, the area of the triangle is once again 24 centimeter square. Okay, so in order to use Heron's formula, we have to know all the three sides: small a, small b, and small c. Only then can we find a semi-perimeter, and then we can use the Heron's formula. Right, so the first part of what we'll be trying to find are the three sides: small a, A, B, and C. Okay, now let's go back to the equation. The length of the two sides of a right triangle containing the right angle. So when you look at this, is the right angle, right? What are two sides? BC and AC. Differ by 2. So we're going to take one to be x, the other to be y. The question says those two sides differ by 2, which means x minus y equals 2. Difference means subtraction. Okay, and then we're going to take a condition where we're going to say x is greater than y. All right, so now let's start. We'll try to find all the three sides. Okay, that is what we'll be doing. Now this minus y, I can send it to the other side. It is going to become plus y. Right, now since this is a right triangle, we know it has a base and a height, which means we can use the area of triangle formula, half base into height. Okay, and if you look at base is x and then height is y, right? So base is x, height is y, and they've given us the area 24 centimeter square. Next step, we'll substitute this y. Okay, in place of we'll substitute this x. In place of x, can write it as 2 plus y, because you can see x equals 2 plus y. So I've written here 2 plus y. All right, once we're done with the next step, we'll send this 2 cross multiplication to the other side. So we're going to have 24 into 2. Right, now let's multiply x into 2, y into 2, 2y, y into y square. All right, then 24 2s are 48. I'll bring it to the left side. It's going to become now minus 48. Right, so you can already see here. Next step is to split this 2y into 2 parts, or splitting the middle term. Okay, so we have the constant here 48, and remember y square, what is the coefficient? 1. So we simply have 48. Right, they can write it 8 6 are 48, and 8 minus 6, do we get 2? We get a middle term 2. Also, when we multiply these two, do we get the constant 48? We get it. All right, so the two terms are what? One is 8 and the other is 6. Okay, so 8y and minus 6y. Right, now when we look at this two, can you see the y is common? So I'm going to take out y common here, and because this is square, I have one more y. This y already taken out, so simply 8. When you look here, minus is minus and 6 are common. This will be y. Okay, so I'm taking minus 6y common, then here from here only y will be left, and 6 8s are 48. All right, then y plus 8 we'll take it, and then what are we left with? Y minus 6. So from here you will see that we're going to get two values of y. Okay, y plus 8 equals 0, y minus 6 equals 0. If I send this to the other side, minus, send this to the other side, plus. Right, so now we already know that the length cannot be negative, so we're going to take y to be equal to 6. Now we found one side, we'll still find another side by substituting. Okay, so putting the value of y equals 6 centimeter in equation 1, which is this. Right, now y, how much we got? We just got it to be 6. So 2 plus 6, 8. Now if you look at the diagram again, the right triangle, now we know two sides. We still need to know this side in order to use Heron's formula. So here we'll be using the Pythagoras theorem. The square of the longest side is equal to sum of the squares of the other two sides. Okay, the longer side is this, and these two are the other sides, squares. Right, and AB, how much we got? Or AB is our y, we got it to be equal to 6, so 6 square. And then BC, how much we got? BC, which is x, we got it to be equal to 8 just now. Right, so 8 square. 36 plus 64 is 100. Send this square to the other side, we're going to get root of, and then so we know the 100 is the square root of 10. Right, so now we know all the three sides. So since we know all the three sides, we just have to put it straight in Heron's formula. But before that, we have to find the semi-perimeter once again. Okay, so here we'll take A to be 10, B is 8, and C is 6. So add them, and then we're going to get how much? 24 by 2 equals 12 centimeter. All right, now we know the semi-perimeter, we just have to diagonally put it in the Heron's formula. Right, then semi-perimeter is 12, then 12 minus 10, 12 minus 8, 12 minus 6. Once we're done with that, let's do the open and bracket subtraction. Okay, 12 minus 10 is 2, 12 minus 8 is 4, 12 minus 6 is 6. Okay, then now I'll multiply this to 6 to the 12. Right, and 4 can be written as 2 into 2. So now what are we getting? Pairs. Right, 12 square into 2, both of them will come out, and then 12 to the 24. So if we go back to the beginning, we're asked to prove once again that it is 24 centimeter square while we're by using Heron's formula, and we already got it here that even by using Heron's formula we get the same area, 24 centimeter square.